Hi, my name is Mirza.
I'm Rachel.
Mustafa,
I'm Ted.
and this is our 154 floor sweeper mechanism. This is our floor sweeper. It collects nuts, screw, and dust from the machine shop floor. Floor sweeper operate by 12-volt DC motor attached to the ground link, and also the motor connected to the crank. So the crank will rotate 360 degrees by the motor to operate the mechanism.
For the geometric design, we designed a crank rocker 4-bar linkage that follows a specific coupler curve based on the atlas it curves. In addition to the linkage, we also designed 2 motor housings on either side of the bin. To balance the floor sweeper and to prevent tipping, a caster wheel is mounted on the back of the bin.
For force analysis, we needed to find the torque on the coupler required to keep the 4-bar linkage in motion. Here are the free body diagrams of the rocker and the crank. On the crank, you can see the torque that we are trying to find. Here is the free body diagram of the coupler, which is our sweep head. Some of the idealizing assumptions we had to make were that the bristles on the broom would not bend, that the friction between the bristles and ramp is negligible due to a perfect match between sweep head and ramp, and that the debris was a point mass normal to the sweep head. Based on our free body diagrams, we formed equations of motion. Then we placed the values in a matrix and solved for the required torque on the coupler, which was 0.12483 Newton meters.
For our stress analysis, we decided that our mechanism was most vulnerable to failure if the crank failed in bending, as its sections were subject to moments due to the motor and the coupler due to contact with debris. Under these assumptions, the upper surface of the crank was most likely to fail due to tension from the maximum bending moment and axial stress. We used a shear and moment diagram and section diagram to find maximum tension. After comparing this tension to yield stress of our proposed material, ABS plastic, we concluded that the crank was unlikely to fail under maximum loading.